connected DD. The port number 3, one piece is connected EE, and with port number 4, another switch is connected. Another switch 2. This is switch 1, and this is the main switch. Okay.
Okay.
So switch is so intelligent that what switch will do is switch will create a MAC table. Switch will create a MAC table, which is also called as layer 2 table. All right.
MAC table. Okay.
MAC table is also called as layer 2 table.
Hmm.
Okay. In MAC table, switch makes the entry. How switch makes the entry? That I am going to explain you. Don't worry. Now for timing, just understand that in MAC table, switch maintains the MAC table. In MAC table, it is mentioned that from which port, which PC is connected. Let's say from port number 1, one switch is connected, and to that switch, 3 computers are connected, A, B, and C. So it is written that port number 1, A is connected, port number 1, B is connected, port number 1, C is connected. It does not mean that on one port, 3 computers are connected. It is impossible. I have shown you the switch, right?
Yeah,
I
yeah,
have
yeah.
shown you the switch
So it will
where it
match
says,
the port number and MAC address.
yeah, it will match the port number and MAC address. All right. So it will that okay on port number 1, 3 computers are connected. It does not mean that on one port 3 PC are connected. On one port, one switch is connected, and to the switch 1, 3 PCs are connected. The MAC address is this.
Yeah.
Okay, so similarly on port number 2, DD is connected, port number 3, E is connected, and port number 4, another switch is connected, which is switch 2, to whom another 3 computers are connected, FF, GG, and HH. Right.
Yeah.
So till here you understand each and everything about the topology.
Yeah. Yeah.
Now see how intelligently switch will make the MAC address, switch will make the entry and all. See here. Now let's say this A wants to communicate with this E, and I assume that A knows the MAC address. Okay.
Yeah.
So A will create a unicast frame, right?
Unicast
And
frame. Yes.
yeah, unicast frame, and it will send it to is this switch.
Yeah.
Now this switch will check its MAC table.
And it will forward
It,
to
yeah, yeah. It
port
don't have
one.
an entry of it only have entry of A, B, and C, right?
Yeah.
So when this switch checks for E, there is no entry. So what
Mm.
this switch one will do? It will tell that okay, for further more detail, I will sending you to the main switch. So it will send it to the main switch, right?
Mm.
Now what this main switch will do? First of all, it will read the source MAC address. It will read the source MAC address. Okay, from where you are coming. So this frame will tell that I am coming from AA. So switch will say, okay, you are coming from AA. All right. Let me check from which port you are connected. So you are connected on port number 1. If if the entry is already there, then this entry will get refreshed. If the entry is already there, so the entry will get refreshed. But if suppose the entry is not there, then what happened, right?
It will update the entry.
If the entry is not there, then switch will make the entry against the port on which it was received. So it is received on port number 1. So switch will make the entry AA. Got it?
Yeah.
So it means if entry is there, then switch will refresh the entry, and if entry is not there, then switch will make the entry against the port on which it was received. Till here, you are clear everything.
Yes.
Now, switch will ask the next question: where you want to go? Destination MAC address. Where you want to go? Where you want to go? So it will tell I want to go to EE. So switch will tell okay. Let me check where EE is connected. So it is connected on port number 3, right?
Yeah.
So switch will only send to port number 3 and not to all other port.
Mm.
Got it till here?
Yes.
But but let's assume that if EE entry is not there, then
Mm-hmm.
what switch will do? Right? Then what switch will do? If EE entry is there, then switch will forward the frame to relevant port only and not to all other ports. But if EE entry is not there, then what switch will do? So in that case, if receiver is not known, in that case, switch will forward the frame to all other ports. It will send it to everyone.
It will
Okay.
broadcast.
No, it will not broadcast. See, switch cannot broadcast. Switch don't have a feature of broadcast.
Okay.
Switch cannot broadcast. Switch forward. There is a difference between broadcast and forward. Broadcast is done by computer. Switch receive the broadcast and forwarding. The switch nature is forwarding, not to broadcasting. All right.
So it will forward all
It
this
will
all the
forward to
ports.
all other ports. Yeah, all other ports. So now what happened? Now what happened? All the computer receive the frame and forward block the frame, right? Because that
Yeah.
is a unicast frame. Except E. E will accept the frame, right?
Yeah.
Now E will accept the frame. Okay, this frame is coming for me. So now what happened? E will reply. So for reply, E will create a frame that from EE going to AA. This is the source MAC and this is the destination MAC. Now E will send this frame to port number 3. So as usual, whenever switch receives the frame, it first asks for source MAC address, right?
Mm.
That hey, from where you are coming. So the frame will tell that okay, I am coming from EE. So switch will say EE. Wait, let me check where you are connected. Okay, there is no entry for EE. So switch will make the entry, and this is how the entry will comes in switch MAC table. This is the real hands-on experience I'm sharing with you. Got
Okay.
it?
Yeah. And
And
also
then
it will forward the frame to
yeah, to
a.
relevant. Yeah, now it will ask from where you want to go. AA. Let me check. A is port number 1. Then only to port number 1 it will send. And to this switch and AA will receive the frame. See, no PC can receive the frame in between.
Mm.
So that is why switch is called an intelligent device. Got it? Now
Yes.
one more thing. Switch is also called as layer 2 device.
Yeah.
And this is a favorite interview question. Why switch is layer 2 device? First they are going to ask you that tell me hub is a layer 1 or layer 2. So you will tell that hub is a layer 1. Then they are going to ask you, okay, switch is layer 1 or layer 2. Then you will tell switch is layer 2 device. They will say, okay, what is the difference between this? So you will tell that hub is a layer 1 because it is physical in nature and used to connect to communicating pairs. That is why hub is a layer 1 device. Then they are again back to the question that okay, then switch is also physical in nature. Switch is also used to connect two communicating pairs. Then how come switch is a layer 2 device? So the answer is switch take forwarding decision on the basis of MAC table, and MAC table is layer 2 table. That is why switch
Okay.
is a layer 2 device. See, if I remove MAC table from switch, then switch and hub act like a same, right?
Yeah.
This is the MAC address in a switch which makes the difference between hub and switch, right?
Yeah.
If you remove the MAC address from the switch, then switch are not able to forward the frame to relevant port only. Switch knows the MAC address, switch knows the frame, but without MAC table, it cannot forward the frame to relevant port. Instead, it will forward the frame to all other ports, right?
Yeah.
So switch take forwarding decision on the basis of MAC table, and MAC table is layer 2 table, hence switch is layer 2 device. Got it?
Yeah.
This is an interview most asked question in interview. Why switch is layer 2 device and why hub is layer 1 device? Hub don't understand MAC address and anything. Hub works on electrical signal. Electrical signal comes under layer 1. Got it?
Yes.
All right. Now, one more important point about the MAC table is, see, switch maintains the MAC table, right?
Switch maintenance. Yeah.
Maintains the MAC table. And MAC table is a very important factor for switch. So MAC table size should be precise and concise. There should not be much entry in the MAC table. Okay. So to keep MAC table size precise and concise, to keep MAC table size short, why short? If MAC table size is long, then it will consume memory.
Mm.
Anything which increase in your mobile phone or computer, that occupies the memory, right?
Yeah.
So if MAC table size is long, there are too many entries in MAC table, then first of all it will consume memory. Secondly, if MAC table is full, then switch is not able to quickly identify an entry, right? It will take time.
Yeah.
It will take time to find an entry. In thousand of entry, it will take time as compared to in 10 entries, right?
Yeah.
So that is why switch MAC table size should be small. So what switch will do to keep MAC table size small and compact, so that switch work in a more efficient way? So what switch will do? Switch will delete the stale entry. Switch will delete the stale entry. Now what is
After.
this stale entry?
Yeah. What's that?
Yeah, stale entry are those entry which is not receiving any frame nor forwarding any frame
Okay.
for a particular period of time, and time is 5 minutes to 30 minutes, depending upon switch to switch and manufacturer to manufacturer. Most probably it is 30 minutes. Okay,
Thank you.
so let's take an example. We have a two colleagues and we go for a break for 1 hour. Okay, all right.
Yeah.
They go for a break for 1 hour. So what they will do? They shut down their PC. They shut down their PC, and he is also shut down their PC and go for break for 1 hour. All right.
Yeah.
Now what happened? My switch will monitor this entry GNH for 30 minutes. Any entry is sending to, is it is receiving any frame? No. Is he sending any frame? No. So switch will consider this entry as a stale entry, and it will remove the stale entry from MAC table, and this is how switch will only keep those entry which is currently working.
Mm.
But what happen if they are come back from the lunch? Let's say they are come back from the lunch and they on their PC, right?
It will start
So
communicating and it will
yeah,
up.
yeah. If they on the PC, so they must do something. They will open the Google page or Yahoo page or something, right? So what their computer will do, their computer will create a frame, and by learning the source MAC address, it will again make the entry. Got my
Mm.
point?
Yeah.
So it means switch will only keep those entry which is currently working. That is why if user are more connected, the internet gets slow, the
Mm.
communication gets slow, and if user are less, the communication is very fast, right?
Yeah.
Yeah, because this is the reason. So that is why switch is also keep MAC table size short, and it will only keep those entry which are currently working. Okay.
Yeah.
Now the next point is